Hi, this is Darryl Peterson, and I'm the manager of the Applications Engineering Department here at Micromeasurements. We're back with our baseball bat. If you remember from the first video, the goal here was to get a strain gauge installed on the handle of this baseball bat, so basically we could build a transducer. So we used a two-part epoxy. We call it the M-Bond AE10, and the AE10, we mixed it up, and we had about 20 minutes to use it before it starts to get a little too thick or viscous. But we used the AE10 to install the strain gauge. And one of the things that I always like to do after using two-part epoxy like this is to check it the next day. So when you come in, before even you take the clamps off, look at the epoxy that's in the jar and make sure that it's a solid. Because if it's not a solid in this jar, you're guaranteed it has not solidified underneath your strain gauge. So again, you mix up an epoxy, you use it, check it the next day, and let's see if it's a solid, and certainly this one is. So I'm going to take that and move it to the side, and now we're going to focus on the strain gauge. You'll notice I've got a little spring clamp. I'll take that off, and we had formed a metal plate and used a silicone rubber pad to put the pressure over top the gauges. So this goes down over top of the gauge and the tape, and then the little metal plate goes over the top of that to help distribute evenly that pressure. And now is a good time for an optical inspection. So the first thing you want to do when you take the clamps off is to take a look at your strain gauge and make sure that it's in the right orientation. Sometimes you'll find when you clamp things up, they have a tendency to want to move, in particular if you're putting it inside of an oven and using an elevated temperature cure. In this case, it looks good. So just from the initial optical inspection, I think the gauge is in the right orientation. I can see the flex circuit on it. I think for the most part, that looks good. So the next step here, I'm just going to remove the tape that's used to hold the gauge in place. Sometimes after it's had a chance to sit for a couple of days, it can be a little bit of a challenge to get it off. But I'll take it, and as you're doing this, just take the tape and kind of peel it directly back on itself, just like I'm trying to show here. So I'm just kind of peeling it back. And once we get on past the strain gauge, it doesn't much matter. You can just take that tape and throw it away. And again, now's a really good time for an optical inspection. So I'll hold it up so you can see it. We've got the strain gauge, we've got the flex circuit. Everything looks to be intimately bonded onto the surface. You can see a little bit of extra flow out of the epoxy, which that's pretty typical. If that were a concern for you when using the M-Bond AE10, one of the little tricks you can do is just mask the area around it to kind of control that flow out. In our case, it doesn't much matter. But I'm looking at it, so I see the gauge, I see the flex circuit. I think we're good. So from an optical standpoint, I think we're ready to go ahead and start attaching the lead wires onto the flex circuit. Now I'm left-handed, so I'm going to take this and kind of move it around a little bit to make it easier for me. I'll just roll it to this side, and really all that I have to do is connect the wires onto this flex circuit. And in order to do that, I'm going to use this soldering unit and a small little roll of solder. This is our 361A-20R-25, and what that means, it has a melting temperature of 361 degrees Fahrenheit. The A means it has a little bit of antimony in it, which helps at cryogenic temperatures to prevent tin disease. The -20R, that's the diameter of the solder, and the R means that it has a rosin flux core. So there's actually a flux inside of the solder. You can't really see it, but it's in there. And then the -25, what that means is that this solder is on a 25-foot spool. So I'm going to take that, and while my soldering pencil starts to heat up, and I'm going to dial the temperature up to what we refer to as the 361 band. And basically that's the right temperature range for using 361 solder. With our soldering units, we call them the Mark 10. It has an adjustable range on it so that you can set it to the right operating temperature. Some of the digital ones now, you just set them to a digital reading. This one, is a style where I can just adjust it to the right temperature range. So I'll take that, lay that to the side. And what I like to use is a couple of gauze pads to clean the tip of the pencil. So I'll just take those and kind of lay them out here on the piece of paper. And let's see if this thing is warm enough to solder, and it looks like it is. You can see the solder is coming off. And all we need to do here is just re-tin the tip of the pencil like that. So the next step, what I'm going to do is tin the tabs that are on this flex circuit. Very simple, very easy. What I'm going to do is take the solder, lay it right over top of the target, press the iron through, and then lift it up. Really that simple and that easy. Now I'll hold it up so you can see it. But now I've got those tabs, tinned, and now they're ready for the lead wire. So I'm going to take that, just put that back down. And I've got this bundle of lead wire that I'm going to use to connect onto this baseball bat. Now we need a little bit of distance between the bat and the data acquisition because we're going to actually try to hit a pitch with this baseball bat. So I've got coiled up here about, roughly speaking, about 15 feet of a vinyl insulated lead wire. If you look at it closely, you'll see it's color-coded red, white, black, and green. I've already stripped the ends of it. And now what I need to do is prep the end of this wire so that I can connect it onto this flex circuit. So I've already gotten the vinyl stripped. And now what I'm going to do is open up my toolkit and take one of these dental picks. This will be hard to see in the camera, but I'm just going to separate the conductors like so. And then I'm going to twist these tightly all the way down to the insulation, because basically what I'm doing is getting these ready to attach onto the flex circuit. And I'm going to twist them, and then I'm going to tin them. Makes our life a little easier when it comes time to connect these guys directly onto that flex circuit. So you want to twist them tightly all the way down to the vinyl, all the way down to that vinyl insulation. And again, I've got 4 conductors, like so. I got a red, a white, a black, and a green. And with our color coding system, typically red is P+, white is S-, black is P-, and green is S+. So P+, S-, P-, S+. The P would be excitation, or maybe you think of it as power, and the S's would be signal out. So the red and the black wire is where I'm going to send power into the circuit. The white wire and the green wire, that's where I'm going to read the signal back out. Now before I connect it, a couple of other things I want to do, which that is I'm going to tin the ends of this wire. So I'll take the soldering pencil, move the dental pick out of the way. Again, clean a little bit of solder off of it and put a little bit more back on it. And I'm going to move the baseball bat just so you can see this. Lay that to the side. I'm going to take the wire and the solder and watch how I kind of feed the solder in at the same time. So I'm going to do the red one, the red conductor. This is the green one. Notice you see a little bit of smoke burning off. That's the flux that's coming off of it. Just like so. And the last is the P- connection here, and I'm just kind of pulling that along through there. So now if I hold it up so you can see it, I've got the 4 conductors. They've been twisted and they've also been tinned. So now what I'm going to do is I'm going to trim these down to the right size for connecting onto that flex circuit. So I'm going to take the soldering pencil, kind of move it out of the way, look inside of my little toolbox over here, and take out the diagonal cutters. I'm just going to shape them a little bit, and then take that and trim those off, because we don't need all that extra conductor. It's going to be kind of tough to see in the camera, but we only need a very small amount of that conductor exposed in order to connect onto the flex circuit. If you look at it closely, you'll see I've got a very small amount, roughly speaking, maybe a 1/16 of an inch. One of the other things I need to do, though, is separate the red conductor from the white from the black, and the black from the green, because I need a little bit more room when I go to connect it onto the flex circuit. So I'll take the diagonal cutters. You could use a scalpel to do this if you want to, or maybe even a straight edge razor blade. I'm going to use these diagonal cutters, and I'm just going to nick the insulation ever so slightly between the green and the black, and I'll pull that out a little bit, and the red to the white. I'm just going to reach in there and just nick that ever so slightly. Pull that back a little bit, and then do the same thing between the white and the black. Let's see if I've got it. Pulling back just a little bit. Just helps me to give a little bit of room to connect onto that flex circuit that's on the strain gauge. So there you can see a view of it, how I've separated them. Yeah, that's probably a little too wide. I'll shape them a little bit. And what I like to do when I start to solder these in place, usually I kind of start in the middle. I'll start with the white and the black conductor first, solder one of those on, and then I'll go to the red and the green. And typically, there's a bunch of different ways you can wire this. I'm going to wire it on this flex circuit. I'm going to start with the red conductor on the left. You can flip-flop it. You can change the color of the wiring. It's totally up to you how you want to wire this. I'm just going to try to use the standard color coding system that we use here at Micro Measurements, which is, again, P+, S-, P-, and S+. So, reach over and grab the baseball bat. I'm going to roll this around. Get the tools out of the way. And this is where, if you got a roll of paper drafting tape, this will kind of help you hold some of this stuff in place. If you ever wondered why we offer paper drafting tape, we use paper drafting tape because the mastic is not very aggressive. So like if you go and you get like painter's tape and stuff like that, you'll find it comes in different grades of tackiness. And in general, paper drafting tape has a very low tack, so it's very easy to get it off. So in general, we're using it only temporarily to help hold the wire in place. And then once we get everything soldered up, then we're trying to remove it. And the idea is that you want to be able to remove it without damaging any of the wiring or the strain gauge or any of that. So we don't want a tape that has a real high tackiness to it. We want one that has low tack, and that's paper drafting tape. So I'm going to take about 1.5 inch piece of it. I'm going to take the wire and kind of wrap it around. Turn it so it's a little bit easier. And what I like to do is take the tape and put it up close to the edge of the wiring, maybe within about, I don't know, maybe 1/4 inch or so. And then I'm going to take it, put a little bit of a loop in this wire. It's hard to see in the camera, but a little bit of loop, because what I want to do is I'm going to press this stuff down, and that'll flatten out this little loop. And when it flattens it out, it'll help push down on top of the strain gauge. A lot of times you'll find with wiring a strain gauge, a lot of times the wires want to stick up out of the connection rather than go down into it. So this is kind of a way to help sort of counter against that a little bit. I'm just going to shape those a little bit more. And then I'll take it and tape it down into place. Just going to try to get it close for now. Try to get that those middle two conductors in place. Sometimes on a curved surface like this, you may have to use a pair of tweezers to kind of help you along. I'm going to roll this around so we can see it a little bit better. So I'm going to start with the white one, then I'm going to scooch the black one over. Scooch is a technical term. And then we'll put the white one on, then we'll put the black one on, and then the other two. Sometimes it's helpful. See, if you think about it, you've already got solder on the wire. You've already got the tabs tinned. So really all this should be is adding a little bit of heat to it, getting it to reflow together. You need heat, really, and you need flux. And sometimes you'll find if you bridge the gap between them, you just have to lift it back up and do it again. I'm going to put a little bit more of a curve in that. You just need a little bit of solder on the tip of the pencil. Sometimes too, if you have a little bit of liquid flux, that can help you to get these in place. I'm going to use the tweezers to help push that wire over. Press it down. And do the same thing for the green one. And then last but not least will be the red one. And sometimes you'll have to shape it a little bit more just to get it to go down in the spot where you want it. A little bit more solder on the tip of the pencil. Okay, and now is a good time for us to optically inspect it. So we're going to take a minute and take a look at it under a microscope, and let's see how we've done, and then we'll come back to it.